Hey everybody, I wanted to take a second and kind of wrap up section, kind of chapter 4, the end of it when we work on rationals. Let's go through this and we're going to take a look. It says, given the following function, find if there are any holes, if so, the x value where the hole would occur, vertical asymptotes, horizontal asymptotes, x-intercepts, y-intercepts. So any of these problems, the first thing you should always start by doing is if you can factor either the numerator or the denominator, you should go ahead and do that. So I'm going to take a look at our numerator, and we know the top is going to factor as a difference of squares, right? It's going to be x minus 5, x plus 5. Now the denominator, we're going to use short key. Factors of 5 that add to 6, it's going to be 5 and 1, right? So x plus 1 and x plus 5. And now let's take a second and let me get another pen. Do you see that there are common factors here? You see that there's an x plus 5 in the top and there's an x plus 5 in the bottom. So we know we can cancel those out, but we have to be careful though, because we know that that means that there is a hole when there's a common factor, and the hole exists where the 0 is. So we did a lot of this earlier in chapter 4. So the answer is yes, there is going to be a hole. Sorry, my eraser's not working. Yes, there is a hole. Now how do we find where that hole is? We set that factor equal to 0. X plus 5 equals 0. We're going to get there's a hole at x equals negative 5. Now we can cross those common factors out now that we've stated there's a hole, and there is just x minus 5 over x plus 1. So this is the function that we're now going to work with. Everything else is going to remain the same, but we have to make sure we note there's a hole at x equals negative 5. Now, how do you find the vertical asymptotes? I'm sorry, let me go back for a second. So holes, I'm going to kind of write a few things over here. So holes, we're going to look for a common factor. Vertical asymptotes, to find vertical asymptotes after you've simplified, you're going to set the denominator equal to 0. So take a look. We've got an x plus 1 down there in the denominator. So our vertical asymptote is going to be, sorry, this keeps moving on me, x plus 1 equals 0. So our vertical asymptote is at x equals negative 1. Horizontal asymptotes, you're going to look at degrees. So it's 3 cases. So we're going to look at the degrees. Take a look at the degree of the numerator. It doesn't matter whether you use the simplified one or you use the original one. The degree in the numerator of the simplified one is 1. The degree of the denominator is 1. Similarly, look at our original function. The degree in the numerator over here is 2 and denominator is 2. Since their degrees are equal, what we do is we look at the leading coefficient. So their degrees are equal, right? And I'll take a look. What is the number in front of x squared? There's a 1 out in front of that x squared. Similarly, if we look at this function, there's a 1 in front of the x here. There's also a 1 in front of the x here. So the horizontal asymptote is at y is equal to, the leading coefficient on top is 1. The leading coefficient on the bottom is 1. So the horizontal asymptote is at y equals 1. X-intercepts, you set the numerator equal to 0. So we set our numerator equal to 0. That's going to be x minus 5 equals 0. Add 5, we get x is equal to 5. Now I want to write that as an ordered pair, so the x-intercept is going to be 5, 0. Finally, to find the y-intercept, you plug 0 in for x. So we plug 0 in for x. How do I do that? What happens? It's going to be 0 minus 5 over 0 plus 1. 0 minus 5 is negative 5. 0 plus 1 is 1. So our y-intercept, we write that as a point. Our y-intercept is going to be 0, negative 5. There's a lot of different things to do in each step, but just try to break it down. Try to give yourself a little key hint, whether it's for vertical asymptotes saying set the denominator equal to 0, horizontal look at the degrees, numerator equal to 0 for x-intercept, stuff like that.